Hello everyone. In this video, we will learn about different aspects of thermal conductivity and the different insulating materials. In one of the previous videos, we discussed about the different laws of heat transfer, and when we learned about the law of conduction, which is known as Fourier's law of heat conduction, we defined one property which is known as thermal conductivity. So thermal conductivity, it will tell you about the ability of material to transfer the heat. It means that it will tell you whether the material is able to transfer the heat quickly or not. And from Fourier's law of heat conduction, we came up to this equation, and the same equation can be rearranged so that we can get the value of thermal conductivity from this. On the basis of this definition or equation, experimental measurements can be made to determine thermal conductivity of different materials. We know that different materials store heat differently, and we have defined the property specific heat, which is denoted by Cp, as a measure of material's ability to store the thermal energy. For example, we can say that at room temperature, the value of Cp for water is 4.18 and for iron it is 0.45. It shows you that water can store almost 10 times the energy than iron. It means that as water is having high Cp value, it is having high capability to store the thermal energy as compared to iron. In the same way, the thermal conductivity K of water and iron can also be compared. So let us say at room temperature, the thermal conductivity values for water and iron are 0.067 and 80.2, and it shows that iron conducts heat 100 times quicker than the water. It means that iron is having more ability to conduct the heat. So if you use iron instead of water, iron will conduct the heat quicker. Hence we can say that water is a poor heat conductor, whereas iron is a excellent medium which gives higher heat conduction. And from this we can conclude, like, high value for thermal conductivity shows that the material is a good conductor of heat, and its low value indicates that material is a poor conductor of heat, which is also known as insulator. Now this figure, it will show you the varying ranges of thermal conductivity. So here for different substances like solids, liquids and gases, the thermal conductivity values and their ranges are provided. So from this figure it is very much clear that this is the portion in which we have solids, and from this we can say solids are those substances which are having higher thermal conductivity values, whereas gases are those substances which are having lower thermal conductivity values, whereas liquids are those substances which will have their thermal conductivity values in between gases and solids. Now we will explore the aspect of thermal conductivity related with solids, liquids and gases. So let us start with gases. We know that the molecules of gases are in continuous random motion, and when they are continuously moving, they are colliding with one another and they are exchanging energy with each other. So you can see here that the molecules are in continuous motion, and when they are moving, they are striking with each other so that kinetic energy of one molecule is transferred to the another molecule. Now let us say I am hitting this set of molecule here. So after hitting, what happens is, so here what I have shown is the set of molecule I have here. The same set of molecule is considered, only the difference is this is the set of molecule before hitting and this is the set of molecule after hitting. So when we hit this, what happens is the flame we have here, so flame of the heat source, so it is having higher kinetic energy molecules. So these higher kinetic energy molecules, they will strike the molecules of gas here, so they will impart their kinetic energy to these molecules, and this molecules kinetic energy will get increased. So it will be because of collision, and hence this increase in kinetic energy will again transferred through entire medium with their collisions. Now here we can see that when we are providing heat, what happens is the molecules are moving with higher average kinetic energies. It means that as temperature is increased, temperature of these molecules increased, the average kinetic energy has gone increased, and the molecules are moving with higher kinetic energies, so that when they collide with each other, the transfer of kinetic energy will be more. Now let us say we have here two sets of molecule. So first set is shown by red color and the second set is shown by blue color. So let us assume that first set is having higher temperature and second set is having lower temperature. So what will happen is, as first set is having higher temperature, their movement will be faster. They will have higher average kinetic energies as compared to the second set. And now you can observe here the molecules from first set, they are moving into the second set and transferring kinetic energy from one region to the another. Now let us say I'm hitting the first set of molecule here. So this first set shown here, let us say I'm hitting this first set of molecule, and we have seen before, as we are providing more heat, its temperature is increasing. It means that their average kinetic energies will increase. Now in the same manner, I'm showing here the same sets, set 1 and set 2. So set 1, it is now heated and increased its temperature, because of which they are moving with higher kinetic energies, and hence what happens is the higher kinetic energy molecules will enter into the second set and they will transfer the energy. From this we can conclude that as the energy is given or heat is given, the temperature will increase, and with increase in temperature, the average kinetic energies of the molecules will increase, because of which, as they have more kinetic energies, the molecules of higher kinetic energy, they will collide with the molecules of lower kinetic energy, and because of this collision, the amount of energy transferred will be higher, because the molecule from higher temperature region, it is now having higher kinetic energy. And the same thing is shown here in the graph. You can see here that here we have different gases like hydrogen, helium, oxygen, carbon dioxide, air, and all the gases are showing the same kind of thing. As we are increasing the temperature, you can see that on y-axis we have thermal conductivity. So as temperature is increased, the thermal conductivity is continuously increasing. So from this we can conclude that as temperature increases, thermal conductivity of gases also increases, and it is because as temperature is increased, the collisions will increase, and because of which the heat will get transferred quickly. Now let us move on thermal conductivity related with liquids. Now the physical mechanism of thermal energy conduction in liquids, it is same as we have studied in gases. In liquids as well as gases, the energy is transferred due to collision of molecules. But the situation in liquids, it is more complex as compared to gases, because the molecules are more closely spaced in case of liquids. Now here you can see that the molecules of liquids, they are closely spaced, whereas the molecules of gases, they are far apart, because in gases there are no intermolecular force of attraction we have, but in case of liquids there are intermolecular forces of attraction. And now because of these intermolecular forces, there is a strong influence on the energy exchange process. So as the temperature is increasing, it is expected that the collisions will increase, but these intermolecular forces of attraction are having influence on their motion, and because of which the energy exchange process is getting affected. And in most of the liquids, it is observed that as the temperature is increased, so we feel that the collisions will increase, because of which its thermal conductivity should also get increased. But it is observed that as temperature increases, thermal conductivity of most of the liquids has dropped down. And from this we can see one graph. So in this graph also it is clear that as the temperature is increased, the thermal conductivity of glycerine, light oil, benzene, all these liquids thermal conductivity is decreasing with increase in temperature. But there is one exception, and that exception is water. So in case of water, what you observe, initially the thermal conductivity is increasing and then again it is decreasing. But the phenomena of thermal conductivity dependence on temperature in case of liquids, it is very complex. But in most of the cases we can say that as the temperature increases, the thermal conductivity of liquids will decrease. Now move towards solids. So we know that in solids, the conduction heat transfer, it is because of two different ways, because of two different mechanisms. First one is the lattice vibrations and second one is motion of free electrons. Now we know that when we are hitting one set of molecule, so they will try to move out, but bondings we have in between, because of which the molecule is not allowed to move out, so it will start vibrating. Its vibrations will increase, and these vibrations will get transported throughout the substance, and this is the way with which the conduction heat transfer take place. And this particular part, in which the first set of molecule, when you are hitting, it will try to move out, but the bondings will not let these molecules to move out. These molecules will vibrate violently, and these vibrations from first set it will get transferred to second, and from second set it will get transported to rest of the set of molecules we have, and this is known as lattice vibrations. Second way, it is known as motion of free electrons. So when you are giving energy here, this electron will get energized, so it is not having any restriction, so that it can easily move from this part easily. So because of this energy given, it will get excited and it will move throughout this body, because of which we have higher heat conduction in this particular case. In case of metals, we will have electrons, but in case of non-metals, there are no electrons present. So in case of metals, lattice vibrations along with motion of free electrons is the mechanism of conduction heat transfer, whereas in case of solids, whereas in case of non-metals, it is through lattice vibrations. Now let us go through the graph for solids, and we can observe that copper is metal, so carbon steel is also a metal, and all the metals are showing one thing, and they are showing like, as the temperature increases, the thermal conductivity of metals is decreasing. Why? Because let us say the temperature level is increased here. Now what will happen? These molecules, they will vibrate more, so their amplitude of vibrations is very large, because of which when the electron is trying to get transported throughout the body, these vibrations, what they are doing is they are restricting the motion of free electrons, because of which in case of metals, what happens is, as you increase the temperature level, at higher temperatures the vibrations will increase, and it will restrict the motion of these electrons, because of which we can say that the thermal conductivity will decrease. And from this we can conclude, as temperature increases, thermal conductivity of metals will decrease. Now in case of non-metals, what happens? There are no electrons we have, so as more energy is given, they will vibrate more. More vibrations means more easily and more quickly the heat will get transferred, and hence as the temperature increases, thermal conductivity of non-metals will also increase. Now moving towards the different insulating materials. So here we can see one example in which we have a brick wall structure, and at the center of it we have one material which is known as polystyrene board insulation. So this material, it is known as insulating material. So let us say left face and right face temperatures of this structure, it is T1 and T2, and temperature T1 is greater than T2, because of which heat transfer will be from left to right. And now what happens is, as the heat is getting transferred from left to right, when the heat reaches to this particular part, so this is a structure which is known as insulation, and insulations are having porous structure, so they are made up of fibers and they are porous in nature. It means that there are air voids or air gaps present. Now what happens when the heat is entering here in this particular part? So we have some solid material, and we have some air gaps also. So when heat tries to pass through the air gap, we know that for gases we have the smallest or least thermal conductivity, and hence the restriction provided by gases will be very high to the transportation of heat. But when we talk about solid, so we have air gaps, but we also have some solid structure. Through that solid structure it will get transported, but because of air gaps the restriction will be very high, and hence this is the reason because of which the materials are restricting the heat flow, and such a materials are known as insulating materials. Now the table here, it shows the different insulations and different insulating materials and their respective thermal conductivity values. Here you can see that the thermal conductivity values, they are varying from 0.015 to 36. So very small thermal conductivity values we can get with the use of insulations, and we can restrict the heat flow with the use of such a kind of insulating materials. Thank you very much.